answers. And as we seek to understand more about our universe and our existence, it is the latest scientific tools that allow us to see what was once invisible to previous generations. In the early 1600s, it was Galileo that provided us the tools to see new worlds. Later that century, Newton used his tools to redefine what we thought we knew about the physical universe. Michael Faraday's discoveries made it possible for future scientists to harness the power of electricity. Dmitri Mendeleev created the foundation of the periodic table of elements, which is the backbone of modern chemistry. Then, in the early 1900s, J.J. Thomson's experiments successfully separated ions of different mass, leading his student Ashton to build the first mass spectrometer in 1919. Mass spectrometers allow the accurate determination of molecular weight of atoms or molecules. Specific weights correspond to specific atoms or molecules, so this information can then be used to determine the identity of the components of a sample. Over the past 45 years, AB Sci scientists have continued to develop innovative new mass spec systems that have advanced at a rate similar to the computer industry. By developing more powerful systems that are easier to use, we've now opened the door for more applications, industries, and people to use this technology to get answers quicker and at lower cost. In the simplest terms, AB Sci mass spec systems provide the answers to the following questions. What is in my sample, and how much of it is there? These samples can be food, water, plants, synthetic chemicals, biological tissues, and biological fluids such as blood, plasma, serum, urine, and saliva. In the Florida Everglades, the use of AB Sci mass specs has shown environmental scientists that the biggest threat to its ecology is not what you can see, but what you can't see unless you have a high-performance mass spectrometer. The selectivity combined with its sensitivity make AB Sci mass spec systems better than traditional UV or GC methods. This same technology allows novice users in the food and agriculture industry to easily report levels of contaminants or pesticides in food and beverages. Mass spec is quickly being adopted in the fields of clinical research and forensics. It is the increased speed, accuracy, and selectivity that reduces false positive results and makes mass spec a more desirable choice than traditional methods such as immunoassays. Who else is using AB Sci mass specs? Have a look. Due to the complex nature of most samples, high-performance liquid chromatography, or HPLC, is usually coupled with mass spectrometry to provide physical separation of the components prior to entering the mass spec. Together they are abbreviated LC-MS. Once a sample is injected into the LC, it is forced by a liquid at high pressure through a column that is packed with the stationary phase. Molecules either associate to the stationary phase or are carried in the mobile phase depending on their characteristics. The most common example is reverse phase LC that separates the sample components over time based on their hydrophobicity. From there, the sample travels to the ion source of the mass spec. Although the results of an experiment will give you the mass of a molecule, the mass spec is actually measuring the mass-to-charge ratio, or m/z. A mass spectrometer is made up of the following basic components: an ion source, a mass analyzer, a detector, and a computer workstation. In the ion source, the sample is converted to charged particles called ions in the gas phase. The most common example is electrospray ionization. From there, the ions enter the mass analyzer. Mass analyzers can filter, select, fragment, and most importantly, measure ions of different m/z. There are different types of analyzers, but they all exploit the ions by using electric or magnetic fields to separate and focus ions of different m/z. A popular example is the triple quadrupole that uses alternating RF and DC voltages to separate ions. Once separated, the ions hit the detector. The detector will amplify the signal and send it to the workstation for converting the information into a mass spectrum. Application-specific software can be running simultaneously so that the data gets reported out to a simplified view that even a novice user can understand. To learn more details about these fascinating technologies, go to www.training.abscience.com and take one of our introductory level self-paced e-learning courses. They are free and registration is immediate. As ABScience continues to advance LC-MS technology, it touches more and more lives around the world by providing answers for science and ultimately knowledge for life.